So welcome everybody. Thanks for joining us today. Welcome to our Ecocity webinar on carbon budgets, targets, and our progress to net zero. My name is Cora Halsworth. I'm Manager of Municipal Programs at British Columbia Institute of Technology Centre for Ecocities. I'm joined by my colleagues at the Centre, Dr. Jenny Moore, Director of Institute Sustainability at BCIT, which is the home for the Centre for Ecocities, and by Christina Olson, who's Manager of the Centre for Ecocities, and Ryan Mackie, who's Technical Lead at the Centre. As you know, Ryan will be delivering the main presentation today. Before we get started, I'd love for each of you to say hello in the chat, and possibly, if you'd like, indicate the organization that you represent, if you'd like. And so if everyone can just keep themselves muted while the presentation's going, there'll be time for questions and discussion. So then you'll be able to unmute yourself and contribute to the discussion. So we're looking forward to hearing from you in that way. And through the presentation also, if you have questions, you can enter them in chat. We might be able to address some of them during the presentation, and we'll get to them after the presentation as well. Again, we're recording this webinar so that we can make it available for those that weren't able to attend today and for your future viewing as well. This webinar is part of a webinar series BCIT Centre for Ecocities hosts as part of the Ecocity Peer Network, and it's being made possible with funding and support from Real Estate Foundation of BC. Next slide, Ryan. I'm joining you today from Saanich, British Columbia, which is in the traditional territories of the Kwangin and Wasanich peoples. And so if all of you could please provide, welcome to provide your own territorial acknowledgement in the chat. I see a few of those already coming in, so that is great. On the next slide, I'll share some background on the center. Provide first an overview of what we're going to talk about today. So before Ryan's presentation, I'm just going to give some short background on the Centre for Ecocities and our work on consumption-based emissions. I'll hand over then to Ryan for the main presentation, and he'll share an overview of current consumption-based and sectoral greenhouse gas emission targets. He'll then share an assessment of how these targets stand up to existing best practices and latest climate science. And then he'll provide an assessment of our progress on this transition to net zero. So let's start with some background on the Centre and consumption-based emissions. I know a number of you are familiar with consumption-based emissions, but I do want to make sure we're all on same footing to start. So the Centre for Ecocities, we focus on advancing transformation of cities to become socially and ecologically sustainable through applied research, education, advisory services, and tool development for municipalities and other stakeholders. We're an anchor of BCIT's leadership in this space. Our work is being made possible with funding from and support from BCIT, Real Estate Foundation of BC, and Vancity Credit Union. So our work at the Centre focuses on two key consumption-based metrics. If you'll move to the next slide, Ryan. So these two key consumption-based metrics are the ecological footprint and consumption-based greenhouse gas emissions. And it's this latter piece that we're going to focus on today. But first, I'll share a little bit of an overview of the ecological footprint. This is a measurement tool that we can use to figure out how close or how far we are from one planet living. It looks at the amount of area that's required to support a person or a community's level of consumption, including the area needed to absorb our carbon dioxide waste. So the other key metric we focus on is the consumption-based greenhouse gas emissions. Again, will be the focus of our presentation today, talking about greenhouse gas emission targets, including consumption-based metrics. So these are both important metrics that can help us identify a path to one planet living. We've been working with local governments to develop consumption-based emission inventories and ecological footprint assessments using the tool created by Dr. Jenny Moore on the call with us today. Jenny created the tool initially to help communities understand their ecological footprint, but it also generates consumption-based emission inventories. It was first prototyped and tested with Metro Vancouver, and results were adopted by Vancouver in its Greenest City Action Plan. And we have an online version of this tool, which is currently freely available for use by municipalities municipalities on request by emailing us. So you can get in touch with Ryan and I if you're interested in seeing this tool. So we've worked now with dozens of cities around Canada, many in BC, and around the world to create inventories using this tool. And you can see the results of some of this work on publicly available reports on our website as well. So and I should flag here for everybody, we'll share the notes afterwards as well, sorry, the slides afterwards, so you'll be able to see the slides later as well. So our session, as I said, is focusing on greenhouse gas targets and our progress on emission reductions. And here at the center, as I said, we focus on a specific type of greenhouse gas inventory, the consumption-based approach. So I just wanted to explore what we mean by consumption-based emissions. And for those of you familiar, this maybe is a bit of a refresh as well. And I like to refer to an article I read a little while ago in Vox magazine that really explained consumption-based emissions really well. So I'm borrowing from that explanation here. And what it did was looking at everyday activity of a typical resident in Canada, like driving to pick up groceries. And this explores how consumption-based emissions are connected to us. So many of us drive in Canada to, for example, go to the store to buy groceries. And our cars, unless you have an electric vehicle and use an electricity source that is generated by renewable energy, gives off a certain amount of carbon dioxide. So these would be the only greenhouse gases that you produce directly during the shopping trip. But however, you also induce a whole realm of additional emissions. These include the emissions that resulted from producing and transporting the food items you bought and from producing and transporting the packaging that contained it. By purchasing these food items, you didn't directly produce these emissions, but you induced them. And these emissions are embodied in the items you purchased and are the embodied emissions. So other embodied emissions associated with this activity include the gasoline used by your car, which was drilled, refined, and shipped to the gas station. So that's another level of embodied emissions. And the car itself was manufactured from raw materials and was shipped. All of these activities result in releasing greenhouse gas emissions. You could go even further by considering the phone that you use to look up directions on how to get to the store and the clothes that you're wearing. So all of these activities and items that you purchase result in emissions, and they can contain materials that will need to be disposed of, which have emissions impact as well. So this is all embodied emissions. And the crux is here that the majority of these items we're using on a day-to-day basis are produced elsewhere and imported for our use within communities. So this means that the emissions associated with products are being accounted for in other jurisdictions where they're produced, not included in our community inventories where they're used. And now we'll just move on to the next slide. So this is a Venn diagram kind of explaining how inventories are constructed in communities and comparing it with consumption-based emissions. So most communities and other levels of government construct sector-based or territorial inventories. So this looks at the emissions of the energy we use locally and the impacts of handling waste. And then the consumption-based approach includes the emissions from the energy and goods and services we use no matter where they're produced. So this consumption-based inventory includes imports and travel, all the travel we do outside of our community, but it doesn't include the exports, which are included in a sector-based activities. So this consumption approach considers the full life cycle of emissions of the energy, goods, and services we consume and allocates these emissions to the community that we live in. So it's important to note that the consumption-based approach does not replace the sector-based inventory or traditional inventory, but rather it provides complementary information. And if you look at the communities we've worked with in Canada constructing their inventories on the next slide, we can see that typical communities we've worked with in Canada, the consumption-based emissions are approximately double that of our sector-based emissions. This is because we import so much of our products into our cities and our country as a whole. We're not manufacturing hubs in our cities. So this means we're living in consumer cities, importing a lot of goods and exporting or offshoring a lot of the impacts of these goods production. In contrast, if we looked at other cities around the world, or communities around the world, or regions around the world where they're producing a lot of these goods, their consumption-based inventory would be lower than their territory or sector-based inventory, so it can be flipped in other regions. On the next slide, I just wanted to highlight that this is an equity issue. So this concept of fair share is incredibly important when it comes to climate mitigation. So it's acknowledging that affluent people, like many of us in our communities here in Canada and in other developed countries, that are contributing the most to greenhouse gas emissions and other ecological impacts, while it's the poorest amongst us that are bearing the brunt of the impacts. So this is showing results from a study by Oxfam and Stockholm Environment Institute, and it shows the dramatic correlation between income and emissions. And shown on this slide, 50% of the world's consumption-related emissions can be attributed to the world's top percent of income earners. We in Canada and other developed regions around the world represent a disproportionate amount of these higher impact populations. So this is a strong argument for the necessity to consider a consumption-based approach to emissions inventories as a means to build equity into our climate actions. And next slide. Oh, yeah, sorry, Ryan. So this is, there has been growing interest in looking at these consumption-based emissions inventories. So we, of course, are working on them at the center. C40Cities, which is a global network of large cities around the world that are collaborating on climate action, have developed over 80 CBIs, consumption-based emission inventories for communities. So also Canada has a national level CBI, which isn't really talked about much, but also in 2022, Sweden became the first country to include a consumption-based emissions a target within their climate work. Next slide, Ryan. So the consumption-based emission inventory and ecological footprint results are now helping to inform action in the cities we're working with and beyond. One of the earliest adopters of the consumption-based approach was the city of Vancouver, as I mentioned. The ecological footprint results were used to inform their award-winning Greenest City plan. Also informed the innovative Green Block Community Engagement Initiative, and Saanich and Greater Victoria also embedded consumption-based emissions results in their award-winning climate plan, and more recently included a commitment to measure and track ecological footprint and consumption-based emissions in their updated official community plan. And they're working to engage stakeholders in acting on these metrics through the One Planet Saanich initiative. Many cities are now setting targets and developing policies on embodied emissions in buildings. A number of you on this in this meeting today, City of Vancouver, North Vancouver, Nelson, and others. So lots of action underway on consumption-based emissions. So our core aim is to help municipalities and their stakeholders focus on key impact areas that are indicated through the ecological footprint and carbon footprint numbers. And I wanted to mention that coming soon, we're working on a planning guide with funding from Real Estate Foundation of BC. This will be a BC specific policy and planning guide to address some of these priorities indicated by consumption-based emission inventory, but also advancing equity. So if we have time at the end of the presentation, we'll take some time to discuss opportunities around this as well. And we'd love to consider with you what are the potential barriers and opportunities to accelerate transformative action in looking at these impact areas. Another exciting project we're working on, this is new news. We recently began work on a project with C40Cities, the group that I just mentioned. They're the network of global cities. So we're working on this project in partnership with One Earth Living and Hot or Cool, and it will result in a playbook for cities that will provide guidance and support for action on reducing greenhouse gas emissions associated with urban consumption. and it'll be tailored to regional opportunities and challenges globally. So we look forward to sharing more details on this project in the new year. I wanted to also share an ecological footprinting update on our next slide. BCIT Centre for Ecocities is currently partnering on an international ecological footprint learning lab project, and this collaborative is focused on developing improved methodologies and training for ecological footprint and biocapacity accounting for communities, nations, and around the world. So it's being led by York University, and is supported by Social Sciences and Humanities Research Council Partnership Grant. And BCIT's role in this is to develop bottom-up measurement approaches for the ecological footprinting. We'll be getting funding over 7 years to support graduate students in building their knowledge and skills in ecological footprint analysis at the urban scale. So we'll share updates with you on that as well. And now my intro was a bit longer than I'd initially intended, but I'm going to hand over now to Ryan, who's going to go into the main content of the slides. And I don't know if there's any questions that came up that we wanted to address immediately beforehand, Ryan, but I'll hand it over to Ryan.
Sorry, I've been watching the slides. I haven't been watching the chat. So
all right, we'll come to the
maybe
questions
we'll
later.
continue after it. Yeah.
Yep.
Yeah, no questions in the chat.
Okay.
Great. Thanks, Jenny.
Thank
Excuse me. Sorry, I'm just avoiding a cold, so hopefully I can make it through all this without losing my voice. Thanks, Cora. Before we start, I'd just like to say as well that the information in this presentation is meant to support government staff and others wanting to push for more aggressive climate action. So it's meant to be a resource. It's not meant to be a critique of anyone's climate action efforts. So just keep that in mind as we're going through this. It's not advancing. There we go. All right, so first let's take a look at consumption-based greenhouse gas targets. So you can see in this chart here, if you look where the pointer is here, this chart shows our global greenhouse gas emissions are around 60 gigatons per year. And it doesn't matter whether we use a sectoral or a consumption-based approach, the total's the same. It's just an accounting difference. The global emissions are allocated differently with each methodology, with us taking responsibility for our fair share of current emissions with a consumption-based approach. Now, this means that greenhouse gas reduction targets also need to be the same for consumption-based and sectoral-based emissions. We need to reduce global emissions by the same amount, regardless of who we're allocating the emissions to. So consumption-based or sectoral approaches, it doesn't matter, we apply the same targets. All right, so now that we've established that, let's take a look at the targets that are published in IPCC's AR6 report. And this is referring to the Intergovernmental Panel on Climate Change, IPCC, and their 6th assessment report, and it's abbreviated as AR6, which is their most recent assessment report. So the IPCC is a body of the United Nations, and it was set up to compile and synthesize all of the climate research from around the world. And these targets that we're looking at here, these are for modeled pathways that limit warming to 1.5 degrees with limited or no overshoot. So, excuse me. So this group here on the left, this is for all greenhouse gases or all main greenhouse gases. So carbon dioxide, methane, nitrous oxide, and fluorinated gases. And this group here on the right is just for carbon dioxide, which is the main contributor to the greenhouse gases, by far the main contributor. And these are the targets that everyone is probably more familiar with. Roughly a 50% reduction in emissions by 2030 and net zero by 2050. Now, I'd like to focus on this number right here that I've circled in red, the greater than 50%. What this means is that these targets are based on modeled scenarios that limit warming to 1.5 degrees in 2100 with a likelihood of greater than 50%. So this seems like a pretty low bar to set for these targets. So let's compare with what's used in some other common cases. So we actually have quite a bit of experience driving targets for things that could result in loss of life if they fail. We design buildings, bridges, cars, airplanes, et cetera, piles of different products that could result in loss of life if they fail. And for this example, let's take a look at steel used in buildings and bridges. So typically a factor of safety of about 4 to 7 is used. And what that means is, for example, a steel beam would be made 4 to 7 times stronger than it needs to be to hold a predicted load. So that factor of safety results in a probability of failure for structural steel of 0.0001%. And or for the optimist, a probability of success for structural steel of 99.9999%. Now, compare that to the probability of success of the IPCC targets for staying below 1.5 degrees. And you can see they're nowhere near on the same level, greater than 50% and almost 100%. So which bridge design would you want? The one designed with our engineering standard that we would typically use for designing a bridge, or the IPCC probability of success for staying below 1.5. Now, as an engineer, if I designed a bridge using the same approach as these climate targets, I could be committing what's called a breach of my duty of care. And that's because this is the expectation of our society. This meets our risk tolerance that's evolved over decades and decades of building things like this and developing this standard for that we need to meet for a probability of success. And it varies a bit for different materials and different situations, but it's roughly around that. And everything that we make that could cause serious injury or loss of life must meet a similar standard to this. Now, the response I often hear to this comparison is, can't we just aim for a higher temperature, 2.5 degrees, 3 degrees? And what we mean by that is if we keep the same mitigation pathway of net zero by 2050, then as we raise the temperature from 1.5 up to closer to 3, then the probability of success starts getting closer to what we would want to see here from our case study that we're comparing it to. So let's take a look at that and see if we can just raise the temperature, raise our expectations of what temperature we would get up to if we still keep our goal of reaching net zero by 2050. Now, before we do that, let's take a look at what the difference is between a target and a threshold. So a target is something that we can aim for, like a dartboard. We'd be above, below. We're just kind of aiming for this target. Whereas a threshold is something we need to be on one side of or the other. So for example, for this diver here coming up for air, the surface of the water represents a threshold that must be crossed. And it doesn't matter if the diver is 3 meters below the surface or 1 meter below the surface. They can't breathe until they cross that threshold of the surface. Now, with climate change, targets should be set to keep us a safe distance from a threshold. And I'll show you more about that on the next slide here. So there's a lot on this slide, so I'll just walk you through the key points that we need to focus on. Up here on the top is the degrees of global warming, so 0, 2 degrees. Different climbing tipping points here are listed on the left, and we're currently around here on the blue dotted line here at 1.1 degrees of warming. This is actually a bit out of date. We're a little higher than that now. And then this blue shaded area is 1.5 degrees on the left and 2 degrees of warming on the right. You can see down here, which are roughly the Paris targets that have been set. These red dots here refer to the estimated temperature where each of these tipping points is crossed, and the red shaded areas is the uncertainty in the range of temperature estimates for crossing these tipping points. So as you can see right now, blue dotted line, we've already potentially crossed for these tipping points. We're within the uncertainty range for them. And by 1.5 degrees, we're right at the estimated temperature for 5 tipping points, and we potentially crossed 5 more tipping points. So 1.5 degrees is really a threshold to stay below to avoid catastrophic climate change, not a target. We don't want to be aiming for the point where we potentially crossed all these tipping points. We want to be aiming well below that. Now, if we also now take a look at societal tipping points or social tipping points from climate change now and in the near term, from water scarcity and drought, extreme weather like heat events, flooding, severe storms, and the impact of these on agriculture. Now, I selected just a few statements from AR6 about current and projected impacts from this. So first, the productivity of all agriculture and fishery sectors have been impacted, and it's affecting food security. Roughly half the world's population are experiencing severe water scarcity for at least 1 month of the year. This means that people are struggling to find enough water for themselves, their crops, or maybe their livestock. And this is already happening with 1.1 degrees of warming. Now, in the future, droughts are projected to be at least twice as likely at 1.5 degrees and 3 times more likely at 2 degrees. And lastly, even with moderate climate change, more and more vulnerable people are going to become desperate and displaced, leading to violence and social tipping points. So these are all direct quotes from IPCC's AR6 report. And so just as the climate tipping points, just as with the climate tipping points in the previous slide, the more near-term social or societal impacts are also indicating that 1.5 degrees is really a threshold that we want to stay below. So let's look at our trajectory based on our current level of projected climate change mitigation globally. So this is taking into account all anticipated mitigation efforts. So we're on track to reach 1.5 degrees in about 10 years. And actually, some more recent reports that have just come out are suggesting it's well within 10 years, maybe more like 6. And we're on track to reach 2 degrees in about 20 to 25 years. So obviously, we're not on a path that will mitigate catastrophic climate change. So now let's take a look at what we need to do to get on a path that would mitigate it. So let's go back to our bridge example here. We've answered our question here. Can we just aim for a higher temperature? And answers no. The data definitely suggests that we want to stay below 1.5 degrees, and in fact says that we shouldn't even be using 1.5 as a target. It's really a threshold. We should be aiming below 1.5, but we'll keep 1.5 as a target for the rest of this presentation because that's what all the data is set up that we want to look at within AR6. But keep in mind, it's really a threshold, and we want to be aiming lower than that. All right, so instead, let's apply this probability of success sorry, here that we would use to design a bridge and other things, and we'll use that to derive our climate targets. All right, now I've extracted this entire table from the AR6 report because as you'll see, it's an important table, and I'll just walk you through the key points that we need to focus on as we go through it. But I wanted to pull up the whole table here so you can refer back to it later within the actual document if you want to look at it. So let's focus on this yellow, highlighted yellow line right here. These numbers right here that I'm going over, these are the global carbon budgets to limit warming to 1.5 degrees for different likelihoods or probabilities of limiting warming to 1.5. So 17, 33%, 50%, 83%. So for example, so as of January 2020, when this table was put together, we could emit an additional 500 gigatons of carbon dioxide globally and have a 50% likelihood of limiting warming to 1.5 degrees, or we could have emitted another 300 gigatons and have an 83% likelihood of limiting warming to 1.5 degrees. So we want to look at a likelihood of 99.9999%, which is the standard that we want to look at. So we need to extrapolate out to the right here, and we need to correct for the current year here. So if we do that, I've corrected to January 2024, we're almost there, and extrapolated out to this target we want to meet. And that results in a global carbon budget of about 50 gigatons, which we would use in about 1 year. So this means we should be net zero globally by 2025. So yeah, because we're currently using about 45, or sorry, we're currently emitting about 45 gigatons of carbon dioxide every year. So yeah, which this is slightly higher than what we would be emitting each year. But we're not done yet. We need to look at the fine print underneath the table here. And if we do that, we see there's all these uncertainties listed underneath here. And these first two, plus or minus 550 and 220. So if we add these together, it's plus or minus 770 gigatons of carbon dioxide that are only partially accounted for in these carbon budgets here, and another plus or minus 440 gigatons of carbon dioxide that aren't accounted for at all in these budget estimates here. So again, so that's plus or minus 770 that's partially accounted for, 440 that's not accounted for at all. So you can see the magnitude of these uncertainties is larger than the budgets actually are right here. So if we include or if we account for these additional uncertainties, our global carbon budget to stay below 1.5 degrees actually ran out about 10 to 20 years ago. So hopefully everyone was able to follow that. I'll just recap really quickly here. So if we use a reasonable likelihood of success to derive our targets, so the 99.999%, keeping in mind that this is a likelihood that standard practice in designing a bridge or anything else that we would design. So it's a reasonable expectation to have for our probability of success. Then our global carbon budget to stay below 1.5 degrees ran out 10 to 20 years ago. All right, so we've already used up our carbon budget. So what does it mean? It means we potentially committed to exceed 1.5 degrees already, which means we've potentially committed to catastrophic climate change already. And if we haven't committed to exceed 1.5 degrees yet, then every additional ton of greenhouse gases that we emit reduces the likelihood of limiting warming to 1.5 degrees. Now, it also means that the data doesn't support the current gold standard of a target of 50% reduction by 2030 and net zero carbon dioxide by 2050. And it doesn't support establishing a carbon budget here because we've already used it up. If we apply a reasonable probability of success to the targets, then we've already used up our carbon budget. Now, I just want to pause here for a quick sidebar. We've been talking about carbon budgeting, and we kind of explained what that was as we went through. It's this potential pool of emissions that we can still emit, and we're saying we've used that up. Now, we need a framework for tracking greenhouse gases within a given year within organizations, similar to tracking finances. And there's different terms being used to refer to this. C40 and ICLEI, I think, I'm not sure if others are as well, but at least C40 and ICLEI are referring to this as climate budgeting. So just kind of be aware this is not the same thing. Carbon budgeting is an emissions budget. Climate budgeting is referring more to this framework around greenhouse gas accounting and tracking, similar to how we would track finances. Now, one additional point on that is one of the things within the climate budgeting. One small aspect of it, I think, is that they're suggesting to refer back to these carbon budgets to set your annual limit within your framework, within your climate budget here. But we're saying that this is zero, so that's probably not the best way to proceed with this. We would highly recommend using a different approach to come up with these annual limits to your allowable greenhouse gas emissions within this tracking framework. Okay, so that's the end of that sidebar. All right, science-based targets and thresholds. So in order for a target or threshold to be considered science-based, it needs to be based on science, but it also needs to meet society's expectation of risk. And the second point here is really where IPCC's targets fail. No one's going to walk out on a bridge that has almost the same likelihood of collapsing as it does of staying standing. So why would we consider setting targets at this level for climate change, which has the potential to wipe out our society as we know it? So what targets should we be aiming for to stay below 1.5 degree threshold? We're already beyond our science-based target for net zero. So we need rapid decarbonization and deployment of carbon removal technologies, or CDR. So some examples of some science-based targets that would be supported by the data: net negative greenhouse gases as soon as possible would be a good target, or a return to safe atmospheric greenhouse gas levels as soon as possible. For example, less than 350 parts per million carbon dioxide. This is a debatable level, but this is probably in the right ballpark of somewhere that we should be aiming for. It's getting below this number here. More data that comes in, we'd be able to refine this in the future, but good enough for now. All right, now the slides we've just been going through, they may seem like all doom and gloom, but the odds of limiting warming to 1.5 degrees are still heavily in our favor if we take action to get to net zero as soon as possible. This graphic here is summarizing kind of the whole point of showing you this content we've just gone through. So on this vertical axis here, we have likelihood of limiting warming to 1.5 degrees. Here, and on the horizontal axis, the year that we reach global net zero CO2. So as we just talked about 10 to 20 years ago, we passed this point of 100% likelihood of limiting warming to 1.5 degrees, and we've been going down this line, and we're right around here right now. And what that means is, if we magically reached global net zero tomorrow, net zero emissions tomorrow, then we're a little under 100% certainty of limiting warming to 1.5 degrees. But the odds are still pretty heavily in our favor. We haven't dropped down a ton here. We're still in a pretty good position. But the longer that we take to reach net zero, the farther we slide down this line. And by 2050, the likelihood of limiting warming to 1.5 degrees is little better than a coin toss. It's about 50-50. So now, many of the people that we engage with are under the impression that meeting the IPCC targets of net zero by 2050 will guarantee that we stay below 1.5 degrees. Most people think this 100% here is actually over here at 2050. And it's not surprising that there's a lot of confusion about this. The IPCC targets themselves are not very clear. You recall from one of the first slides that I showed, there's that little greater than 50% in the brackets above the targets. It's, you know, you can easily just miss it sitting there. And that's what's referring to this massive risk here with the associated with reaching net zero by 2050. So that little number in the brackets is referring to this massive risk here. So it's, yeah, like I said, it's easy to miss that. And the majority of references to the IPCC targets don't even mention the risk. And that's the case for media, for climate advisory organizations, and even a lot of scientific papers. They don't even mention this risk. It's just want to limit warming to 1.5 degrees, net zero by 2050, and like I said, no mention of this. So this graphic here, this is showing the reality of the situation we're in, hopefully clearly. And planners and decision makers need to know this in order to understand the risks they're taking in their mitigation timelines to reach net zero, and to address the need to change their procedures to accommodate a meaningful timeline, a shorter timeline. And the public needs to know this in order to support decision makers to act in a meaningful timeline to reach net zero. So we'll just wrap up here with a few recommendations: revisit mitigation timelines, address barriers to accelerated mitigation timeline. So procedures need to align with the rapid change that is necessary, and this could be at the local level, regional level, or more likely in collaboration with senior government. And lastly here, so develop and implement a comprehensive carbon dioxide removal strategy. So, and this is another key point here. So our end goal should be get back to safe atmospheric greenhouse gas levels as soon as possible, right? Net zero is not our end goal. We need to get back to safe greenhouse gas levels. All right, so that wraps up the section on targets, and now I'll look a bit more specifically on progress and how we're doing on implementation and mitigation. Let's start with the building sector. So some of this is provincial, some of this is local as we're going through, some of it's regional. It's kind of mixed. Most of these are kind of from a local government's perspective, and then in terms of so anyway, we'll take a look at it as we go through. There's a bit of a mix. So minimizing energy use. First, there's certainly progress on that. Within BC, there's an energy step code being rolled out, and that's involvement from both province and the local governments, because they have the option to adopt higher step codes earlier. And then we have passive house and net zero standards that are being used nationally for fuel switching to renewables. Again, within BC, zero carbon step codes being implemented, and net zero energy standard again across Canada. So net zero energy standard has an energy use component and a renewables component. So it's in both of these. And then for minimizing material impacts, there's good progress happening here. We're starting to do whole building LCA life cycle assessments. There's environmental product declarations being used here, and some action starting on embodied carbon. reductions and requirements for reducing embodied carbon. So let's just focus on these EPDs for a second and what they are, the environmental product declarations. Now, these are, well, at least for our purposes here, they're product level greenhouse gas life cycle assessments for building materials. And these are essential to be doing these whole building life cycle assessments. We have to know the life cycle of all the materials to be able to do a whole building LCA. And they're also essential for both tracking and reducing these embodied carbon impacts as well, these embodied carbon impacts. So, and we'll talk about these more as we're going through, but this product labeling here that's starting to happen or is happening within the building sector is really crucial, and we'll talk about that more later, like I said. So also we're seeing progress on shift to circularity, more and more policy coming in on deconstruction and reuse requirements. So this is great. This is exactly what we need to be doing. We want to minimize demand for energy so that we can meet it more easily with renewables. We want to minimize the impact from raw material use. Now, there's still a few gaps within the building sector, of course, everyone knows, but some big ones I think are the electrification of construction equipment and generators, and a broader adoption of C40 Cities Clean Construction Declaration might help get things moving in this area. So I encourage everyone to take a look at that. That's a C40 Cities Clean Construction Declaration. And with these whole building life cycle assessments that are being done, these are missing some pretty significant impacts. There just isn't enough data yet to include. So yeah, so they're gonna be changing as we use them more, but you know, it's early days basically still on these. But overall, this is great. The building sector is showing strong, comprehensive movement in the right direction. So now let's take a look at that same framework we just used for buildings, minimizing energy use, fuel switching, minimizing material impact, and look at that for the other categories that we kind of shuffle things into at the center, the building sector, the transportation, food, and consumables and waste. So we'll start with transportation here and now. Now, by far the best way to reduce impact from transportation in our cities is to eliminate the need for private vehicles. And the best way to do that is to reconfigure our cities into complete compact communities. Now, this has been talked about for a long time, and some progress is being made here. It's being included in more and more official community plans. And in BC, all signatories to the province's Climate Action Charter have actually committed to developing complete compact communities already. But there's still a lot of momentum to continue developing urban sprawl that's dependent on private vehicle use. So some progress here, but certainly a lot more work to do. So progress on active transportation as well. So there's certainly a lot of progress here. I see increasing mode share for active transportation and transit, and remote work, telework, virtual engagement. This is becoming more the norm for everyone, at least part of the time, but yeah, probably there's a fair bit more we could do with this. Now, all of these, the combined impact of these have huge potential to reduce energy use within the transportation sector. Now, fuel switching to renewables, of course, there's a lot of progress being made on electrification. Pretty much every jurisdiction is working on this. You know, we were out for a family vacation in the summer, and we were in a small town that was so small that roads weren't even paved. It was all gravel, and there were 6 Tesla chargers sitting there in the gravel parking lot. So you know, it's pretty much everywhere is working on electrification, which is great to see. Now, minimizing material impact. we'd expect to see some reduction in vehicle ownership through the expansion of active transportation, transit, car and bike share. So we're not really seeing this yet, but yeah, that's at the expectation over time. We should see vehicle ownership dropping. Now, there are some trends, I guess, taking us, well, some of them in the wrong direction, but others maybe just not far enough in the right direction. So let's take a look at these quickly. So vehicle sizes are increasing, and EVs still use a ton of energy. This claims of low carbon fuels and vehicle sizes down here in materials as well. So they're impacting energy use and material use. So let's look at these three things quickly. So first, vehicle sizes increasing. Now you can see from the Stats Canada chart, Statistics Canada, there's been a huge increase in the percentage of new vehicle sales that are trucks and SUVs. And if you continue this down, previously it keeps going down into the 90s and it keeps going up here past 2020 as well. We're well up over 80% now, I believe. So the average truck or SUV weighs about 65% more than the average car. And the weight of a vehicle is a pretty good indicator of how much energy it will use. A vehicle that weighs twice as much as another vehicle is going to use roughly twice the energy, assuming the vehicles are powered the same. So if they're both hybrid or they're both gas, you know, the weight's a really good indicator of how much energy it's going to use. So the increase in vehicle size is offsetting gains made through efficiencies, hybridization, electrification, and it's also increasing the impact from materials. Bigger vehicles equals more materials, and is offsetting potential gains made through reducing vehicle ownership. Now, I haven't seen this talked about a lot, but there was actually a paper that just came out recently talking about, what did they call it? This is the SUV, the impact of the SUV trend. And I think they, don't quote me on this, but I think they were saying that if the SUV trend had not happened, then transportation emissions would be 30% lower, or 33, somewhere around there, low 30s, lower than what they are currently. So yeah, if you're interested in it, it's a good report. You can ask me later, put in a link to that. All right, EV is still using a ton of energy. Now, to start with, don't even worry about whether this is an EV or a gas vehicle. It doesn't matter. Let's just look at the total weights here. So if we look at, or if we assume the average weight of a passenger is around 70 kilos, and compare that to the weight of the car, and look at the percentage of the weight that is actually the passenger versus the total weight of the car and the passenger together, we can see for the average car, the passenger makes up about 5% of the total weight, and for a truck or SUV, it's around 3%. So as you recall from the last slide, weight is a pretty good indicator of energy use. So we can say roughly for these cases here that 95% of the energy goes into moving the car here, and 5% into moving the passenger, and for the truck or SUV, about 97% of the energy goes into moving the truck, and only about 3% goes into moving the passenger. Now, the objective is to move people, not steel and plastic. So almost all the energy is wasted in private vehicles. Now, compare that to a transit bus, where passengers can account for up to 50% of the total weight. Now, in order for private vehicles to compete with a fully loaded transit bus, they need to look like this. Small, e-mobility, and in fact, this electric Vespa is probably a bit too heavy to compete with a fully loaded transit bus. We're looking at more like something like this, which is an electric unicycle. So small micro-mobility to compete with transit. Now, just to cap this off, we're not saying EVs are bad. We still need EVs, but we need to maximize the shift to active transportation and transit. And we need to shift incentives for EVs to smaller EVs. So, for example, smart car EV is only about 1,100 kilos. Nissan sells a compact EV in Asia that's only about 1,000 kilos. So we want to shift incentives away from EVs that are, 2,000, 2,500 kilos. They're massive, and shift those down to EVs that are, 1,500 kilos or less, and that could be a scaled incentive or something like that. All right, now claims of low carbon fuels. So compressed natural gas, or CNG, has been promoted as low carbon fuel by some transit authorities. Now, it's true CNG does emit less greenhouse gases than diesel, but CNG engines are also lower efficiency than diesel. Now, these two things cancel each other out, and a CNG bus emits about the same greenhouse gases as a diesel bus. Now, this is important for a few reasons. Adopting CNG has delayed the electrification of transit in many jurisdictions. We're at least a decade behind where we could be in transitioning our transit fleets to electric. In 2016, almost 8 years ago, Europe was putting 25,000 electric buses on the road in that year alone. China put 130,000 electric buses on the road that year, and they've continued to scale up from there. The promotion of CNG as a low carbon fuel has been really damaging to the climate literacy of the public as well. We get questions all the time about these buses and their impact and how green they are and whether they're reducing people's personal inventory or not. So it's definitely had a really negative impact. It's also been damaging to the reputation of the transit authorities. A lot of people are well aware that this is nothing more than greenwashing. So unfortunately, the case for LNG as a marine fuel isn't really any better. Using a 20-year global warming potential and factoring in all of LNG's life cycle emissions, there's absolutely no climate benefit from using LNG instead of marine diesel. Even if we compare it to the dirty bunker fuel being used, there's no climate benefit from using LNG. So natural gas is not a low carbon fuel, and the promotion of it is keeping us on a path to increasing global warming. All right, so transportation, what's needed here, and want to note this is collectively from all levels of government and really all stakeholders, not just all levels of government, but we're certainly not just focusing on local regional government which are primarily the people in the room. But so accelerated transition to complete compact communities, a metric for system level efficiency, something like kilowatt hours per passenger kilometer, maybe gigajoules, doesn't really matter, some kind of unit of energy per passenger kilometer, because this will really highlight the drastic difference between private vehicles and transit and e-micromobility and things like that, and e-bikes, and really help us shift to better efficiency within the transportation sector. So we want to prioritize active transportation, electric transit over EVs, and accelerate new infrastructure, push back against misinformation and greenwashing. And just as with the buildings, we want these environmental product declarations. We need product labeling to drive market transformation. Now, realistically here for product labeling, Canada is a pretty small market relatively for transportation. So really for this, we wouldn't just be looking at collaboration between all levels of government in Canada. This probably require international collaboration as well. So consumables. Again, looking at the same framework here, minimizing energy use. And so the majority of impact from consumables is supply chains, which for many products is global. It's certainly more of a challenge for governments to have an influence here. There's some limited influence that could be had by local governments over local businesses through building codes and bylaws. We're also seeing a shift here to circularity with share, reuse, repair initiatives that are being done locally and regionally. But really, to have a chance of making a product circular, they need to be designed to be circular. So again, we have this issue of dealing with global supply chains. So what's needed here, and again, just a note, is collectively from all levels of government, all stakeholders, is really key here for consumables, especially since we're dealing with global supply chains. Environmental product declarations, product labeling is really something that would be really beneficial. It's pretty hard for us to buy low carbon products without any way to identify them. So of course, more regulation would help. We want to try and eliminate materials that have no hope of ever becoming circular. All right, food, lastly. Most of the impact from foods in its production at the farm level, currently over 50% of the food produced in Canada is wasted. So well over 50%, actually, it's about 58%. And there's a huge opportunity to make our food system more efficient, minimize demand for addressing food waste. There's progress being made here. There's lots of initiatives at local and regional level. Groups like Love Food, Hate Waste, and Second Harvest are really shining a spotlight on this issue. And promotion of low carbon diets here, shifting diets. So again, local regional governments promoting low carbon diets through their own procurement and through other initiatives. Now, most of the impact from farming is from managing materials. So, for example, soil management. Are the farms using practices that will emit carbon or sequester carbon in the soil? And also managing fertilizers and manure management. Those three things are really the key impact areas for a farm and for food in general: soil management, fertilizer management, and manure management. So local and organic farming is being promoted as a way to choose farms with better practices and lower emissions. But I put them in brackets because it doesn't necessarily correspond to lower greenhouse gas emissions. And we talk about that a bit more in the next slide. But what local production does do is it shortens supply chains, which can be part of a really good strategy to reduce food waste. A lot of the food waste is within our supply chain. Shorten the supply chain, we can actually eliminate a lot of that waste. All right, so what's needed here for food? And again, collectively from all levels of government, we're talking about here, and other stakeholders as well. And just as everything else, environmental product declarations, product labeling. We can't promote good farming practices if we don't have any way of identifying them. Tackling food waste more. There's a huge opportunity here to reduce or improve system efficiency within the food network by eliminating a lot of food waste. Now, regenerative agriculture practices. So what I mean by this, regenerative agriculture it's a set of farming practices that enhance the health of the soil. And in doing that, they build up carbon in the soil. So the agricultural sector has a potential to drastically reduce emissions by shifting to these kinds of practices. And becoming net zero or even net negative potentially by shifting to these kind of practices. And there's lots of farms already doing this and producing food in this way. But again, it's very difficult to promote good farming practices if we don't have any way of identifying them. This next one here, so promote lower carbon meat production. Now, so in addition to promoting a shift to more plant-based diets and reducing demand for meat, there's also strategies to reduce emissions from meat production. One of the most promising are dietary supplements for animals, livestock, that can reduce the methane produced as they're digesting food. And there's a recent study that was put out. Sorry, I'm just looking at the notes. Yeah, so recent studies estimate about an 80% reduction in methane from livestock could be achieved, and that's from a couple recent studies that were out, average between the two. And commercial scale urban agriculture, I put this in brackets. This could be a good strategy in some areas, maybe not for others. I'm in Saanich, and we have farms right around the urban center, so probably not a great strategy for here, but it would be for other areas to bring commercial scale agriculture within the urban environment. All right, and that wraps that up. So next steps, we're in the process of converting the content in the presentation into a report format, basically taking the content of the slides and merging it with the speaker notes so that it's easier to reference, better than the slide deck, just sending that out. And so it can be used as a reference. And Cora already mentioned as well, this is being worked on. She used a different term than policy compendium. I put this in, but this will go into detail on policy guidance to help communities transition to be net negative. And we kind of touched on some of these highlights just as we went through this last section, but so this guidebook would go into much more detail on that. So before we go into questions, I'd just like to repeat that the information in the presentation is meant to be to support government staff and other stakeholders. It's meant to be a resource. It's for people that want to push for more aggressive climate action. It's not meant to be a critique of anyone's climate action efforts. And I'd also like to say, just as maybe a closing here before questions, if future modeling shows that even with more aggressive climate action efforts, like we're suggesting here, more aggressive climate action efforts within everyone's current roles, if that's still showing that it's impossible to follow a path that gives us a high probability of limiting warming to 1.5, then we feel that we would suggest we would want to be advocating for extraordinary measures to be taken by senior government to restructure our economy and remove barriers to the changes that are needed for success. So maybe we're not quite there in terms of taking really extraordinary measures and shifting roles of different levels of government, but I think we need to keep our eyes open. If we're not there yet, we're certainly going to be there soon, potentially, if we can't really ramp up the speed in which we're doing things, which is going to be tough to do. I mean, everyone's already tapped out and going full speed, and there's lack of resources already. So, okay, I'll leave it there.